Okay, so now we will do question number 10.6 from the wave optics chapter of this exercise. So it has two sub questions. First one is easy, the second one is just you have to understand, and it's also fine. So the question states a beam of light consists of two wavelengths, 650 nanometer and 520 nanometer, is used to obtain interference fringes in the Young's double slit experiment. Now, I mean, to understand the question, let's understand the question for extra knowledge or for no reason. Let it be. So a beam of light. So one light. If this is one light, consists of two wavelengths. So now you'll be like, how does one light have two wavelengths? Imagine this is white light. And we keep a prism in front. It will make 7 more wavelengths. One light can make 7 more wavelengths with GR. And what if from that with GR we just take two wavelengths, 650 and 650 nanometer and 520 nanometer, and we let them pass through the Young's double slit experiment. This is slit 1, slit 2, and we take two of this out of the VIBGR. We take two of the wavelength and let it pass. Those will be 650 and 520 nm. Okay, and is used to obtain interference. So these two are used to obtain the interference of light, means to find the bright fringe. So the first question is find the distance of the third bright fringe on the screen from the central maxima for wavelength 650 nm. So for the 650 nanometer, find the third bright fringe from the central maxima. This is a central maxima where the intensity is the most, like the light will be formed here, and this is center. So from this center you should go 3 bright fringe up. So 1 bright fringe, 2 bright fringe, third bright fringe. You should find this. What is the formula for this? X is equal to n lambda d by d. Formula for this is x n is equal to n lambda d by d, where n is the number for which bright fringe you want. Lambda is the wavelength, capital D is the distance between the screen, and small d is the distance between the slit. So if this is d, small d, and this is big D. Okay, so now they only gave n and wavefront. What is n? N is equal to 3. And what is wavefront? Wavefront is equal to 650 nanometer for the 650 nanometer this set maximum. So we know x is equal to n lambda d by d. What is n? N is equal to 3 into 650 d by d, because they didn't give us d by d, so we'll keep it as it is. So then when we multiply this, we get 950 d by d. So this is your answer. So for the third bright fringe, we get 1950 d by d. So this is your first part of the answer. Easy, right? Super easy. Yeah, done. Second one is the tricky part actually. So what is the least distance from the central maxima where the bright fringes due to both wavelength concede? The least distance between the central maxima. So if this is center and this is one bright, this is second bright, this is third bright, this is fourth bright. What is the least distance between two bright fringe? What you can see? 1. What is 3 minus 2? 1. 2 minus 1? 1. 1 minus 0? 1. Now you'll be like, what if you take 4 and 2? What is 4 minus 2? 2. Which is closer, 2 or 1? 1 is closer. So why are we going to take 2? We'll just take 1. So now we know. So 4 will differentiate. So this is for 520 nanometer. This is for 650 nanometer. So we know what is the formula. X is equal to n lambda d by d. Here also. Okay. So now it says distance. So there must be a difference in distance. Okay. So we cannot take the same point. We should take a point which has the least distance. So what is the least distance? 2 and 1. Okay. So I'll take other one. What? So if this is n, if this distance is n and I can make it 2, then what is the least distance between 2? 1 I can do, right? N minus 1 lambda d by d. Okay, do you understand? If this n I take it as 2, then what's the least distance? You can even do 9 minus 1, or you can also do 9 plus 1. It doesn't matter. It will be the same thing. Okay. So now I take n minus 1. Why? Because nearest one is what? 2. What is 2 minus 1? 1. So we should take the least distance bright fringe. Within 2, what is the least distance? 1. So yeah, one right fringe. So now when I compare these two, okay, when I compare these two, n lambda d by d is equal to n minus 1 lambda d by d. When I compare them, this I'll cut, this I'll cut. Why? They are the same. Now what is lambda for this one? 520. So n 520 is equal to, what is lambda here? Lambda 650. So 650 n minus 1. Right, now I can do simple maths. 520 n is equal to 650 n minus 650. Now I'll take 650 to the side, so 650 is equal to 650 n divided by 520 n. Now what do I have to divide? No, wait. So I will take 520 n is equal to 650 n minus 650. So 650 will take this side and 520 will take other side. So 650 n minus 520 n. 650 is equal to 130 n. So n is equal to 650 divided by 130. 0 cut. Then n is equal to 5. I got n is equal to 5. So now I got n is equal to 5. So now if I keep n is equal to 5 in these two formulas, in here and in here, okay, let's keep. So let's keep. So here n lambda d by d, n minus 1 lambda d by d. Okay. So now what is 5 lambda? What is lambda? Lambda, what is lambda? Lambda over here is 520, so into 520 d by d. Okay, now here what is n? N is 5. What is 5 minus 1? 4. What is lambda? Lambda is 650 d by d. Okay, now if I multiply both of them, this I will get, what is 50 into 5? 5 to the 10, 1 carry over, 25, 26 d by d. Here I'll get 6 5 the 20 to carry over, 6 12 8 24 25, 6 12 8 24 25 d by d. I'll do it again. 5 4 the 22 carry over, 6 to 20 26. Okay, here is 26. Now you see 26 d by d, 26 d by d, same. So the answer is 26 d by d. It said what is the least distance. So this is distance basically, right? What is n lambda d by d? Distance. N lambda d by d. What's the formula for distance? For x. So in both I got 2600 d by d and 2600 d by d. So if I equate 5 in any of the formula, I'll get same 2600 d by d. So yeah, that's it. So that's what they were supposed to find. What is the least distance from the center? So I took the least distance. What is the least distance? 2 and 1. I took 2 and 1. They said there should be distance between them, so I take 2 and 1. So here I took 2. So to get the least distance, I'll take it 1. Example, I walked 3 steps front. Okay, 3 steps front, and my friend has to take 1 step difference. Okay, like 1 step less than me. Okay, like 1 step less than me. Like we should be close, but there should be difference between us of least distance. So 1 step you cannot take like 2.5 step. No, we can only round off to 2. Okay, only 2. So if my friend take 2 steps, 3 step, 2 step, close, least distance, he can either take 2 step, 1 step, or 0 step. What is the most closest one? Most least distance? This one, right? So if this is n, then n minus 1. If I take 5, then he'll take 4. If I take 10, he'll take 9. Same way. If this is 2, this will take 2 minus 1, 1. So n minus 1. And then I put the formula, and then I got here, and then both sides you see 2600 is the answer here, 2600 the answer is here. The answer is same. That is why we have to take least distance n minus 1, and yeah, that's it. Or even if you add here plus here, it won't change anything. Okay, if you add plus here, like if I do over here n plus 1, 650, here I'll get 520n, 650n plus 650 is equal to 520n. and this I'll minus 650. But if I take minus 650, you would notice that I'll get answer in minus in minus. Okay, in minus means if you know this is the screen, this is the center, this is central bright, you know, here we go up down like slit, you know, this upside and the same downside, right? So this will represent downside, whereas this represent upside. So it's better to take n minus 1. Why to take an n plus 2? Okay, I'll do it. Okay, I'll get the same answer. So 650 is equal to 650 n minus 520 n. I'll get minus 650 is equal to 130 n plus, okay, and n is equal to 650 by 130 minus is equal to n is equal to minus 5. Is minus 5 possible? Can a fringe can be minus 5? Below the graph it can be minus 5. But why to take that? So you can just use this n minus 1. That's it. So yeah, made it easier. Thank you so much.